Hi, everyone. Thanks for coming. So we had to add some new chairs to the pile, so that's flattering, I guess. All right, so yeah, here's my talk. Several components are rendering client performance at Slack scale. So already got a little bit of an introduction, but yeah, so I used to be a senior staff software engineer at Slack's client performance infrastructure team. As was already mentioned, the team formed in August. Well, you didn't say that, but the team formed in August of 2021 as a result of a little initiative that I started. I wanted to have performance regression testing. How cute. We eventually realized that it wasn't quite the scale of initiative that we needed, so it ballooned into a performance observability little project, and then that became a whole team. And before that, I was on Slack search team. That's how I started at Slack. I guess that was 6.5 years ago. I worked on the desktop autocomplete. So I made that the experience y'all know and love today. I was on that team where I really got into front-end performance because Slack's desktop autocomplete does more JavaScript on the client than you would expect. So there was a lot of JavaScript to do in a very short amount of time. So I proved to the powers that be that I knew how to make JavaScript fast. And then they're like, oh, okay, well, do you want to make it do performance for real? Because we don't have anyone doing that full time at Slack. And then it became that. So now next, I haven't really announced this officially, but I'm going to be working at Notion. So next week I'm starting at Notion. Congrats, you heard it here first, unless you heard it somewhere else first. Yeah, I'll be pretty much doing the same thing I did at Slack, but for Notion. Similar Electron application, I guess. And if you want to see these slides, they'll be up at that link, and I'm Zeigen Vector many places on the internet. Okay, so enough rambling about the teams that I'm on. Performance. I assume most of you are keyed into this because this is a performance meetup, but in case you're just here for the pizza, so what is performance? All right, so, we say it's making the app go fast, reducing latency, buttery smooth interactions, getting rid of jank, no dropped frames. And how do we do this? Well, my number one performance rule is do less work. But ultimately, the real reason why I wanted to have this slide was to hammer this home, which is that we do performance so our users have a great experience. I feel like I'm remiss if I give a talk about performance and I don't make this case, because it's really easy to lose sight of the fact that performance, we like it because we ultimately want our users to be having a good time. Maybe also to make money and sell more products and blah, 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 blah. But user experience. So ultimately, in Slack's case, we wanted channel switches to be fast. We wanted typing. There's a lot of typing into Slack. We wanted that to be smooth. We don't want there to be input delay. The character that you typed should appear on the screen instantaneously. So keep that in mind as I go through this talk, and try and stay rooted in this idea of why we're doing this, why we're here, and why I am talking about this today. Okay, so some stuff about Slack. Many of you probably use Slack as an application. I've even used it within the past week despite not being at work. Slack at its core is a channel-based collaboration tool. There's a lot of text. There's a lot of images, there's files, there's video conferencing. And as some of you maybe know, especially if you spend any time on Hacker News, the Slack desktop application isn't native. It's an Electron, that one, app, which means that it is a web application being rendered by Chromium. So Electron is a framework for creating desktop applications via Chromium. So that means that Slack the UI, it's using good old HTML, CSS, JavaScript, just like any old web application that you would load up inside of Chrome, Firefox, Safari, Arc. So that means that we're subject to the same performance constraints and challenges presented by browsers. So Slack also is a very long-lived single-page application. So you boot up your Slack, and then if you're anything like me and a lot of people, the Slack stays open forever, essentially, unless you quit it for some reason or you're one of those people who diligently restarts their laptop or shuts down their laptop every day when they're finished with work. Like, who does that, right? So Slack stays open, and you're not rebooting it. We had our ways of rebooting Slack for you if we needed to push new JavaScript, but otherwise, Slack's staying open. So we have really, really long sessions. There's no clear page load except at boot, and there's a lot of dynamic content, mainly motivated by frequent updates via the WebSocket. You're typing into it, you're switching channels, someone's React-G'ing, et cetera, et cetera. So what this means is that the classic performance metrics that we know about, a lot of them, they're like based on load, right? Like it's like what's happening at load, like how fast does the page load? What is the initial blah, 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 blah. Or even things like INP, they're really best when the sessions are kind of short and finite and you can have a good chunk of time in which that session doesn't go on forever, because otherwise these things kind of get a little bit muddy. So our problems are less about load speed, which a lot of performance talks and metrics are based on, and much more about runtime speed. So that means that we're focusing on different things compared to a lot of other web applications. And some stuff about browsers, because we have to understand what the browser is doing to understand how to make the JavaScript faster, right? So one of the many jobs of a browser is to convert the code that we send it, HTML, CSS, JavaScript, into pixels on the page. So it's going to do this by creating some trees, the DOM tree, the CSS tree, and then by their powers combined, you get a render tree. And needs to then take that render tree and go through 3 more phases. Layout, where's everything going to go? Painting, what are the pixels that are going to represent these things on the page? So it's going to represent the pixels on screen as a series of layers, and then compositing, which is smushing all of the layers together. And browser, promise there's a point to all of this, and we're very close to it. It's going to try its very best to do this all 60 times per second, provided that there's something that's changing, that it needs to update. So 60 frames per second, or every 16.66 milliseconds. So 16 is a magic number in the front-end performance world. And I think there's a well actually here, which is that this refresh rate depends on your monitor. So it could be even faster than that. If you have a fancy monitor, it's going to happen even faster. But 60 frames per second, 16.66 milliseconds, those are like the magic numbers that we tend to target. All right, but the JavaScript also needs to happen, because most of what we're going to be talking about for the rest of this talk is JavaScript related. So 60 frames per second only happens under the most perfect of conditions, and that obviously isn't going to happen, or else there isn't a talk, because renders are constrained by the speed of your JavaScript. JavaScript is single-threaded, running on the browser's main thread, along with all the style, layout, and painting calculations. So everything gets called in JavaScript is going to go onto the stack. Synchronous calls go right on. Async callbacks, like input handlers, they get thrown into a callback queue and are then moved onto the stack by the event loop once the stack is cleared. There's also a render queue. It's going to try and get all those renders done that we just talked about, 60 frames per second, but renders can't happen if there's anything on the JavaScript callback. So again, if your JavaScript takes longer than 16 milliseconds to run, you will end up with dropped frames, laggy inputs, etc. Things are going to start to feel slow. Your user is going to have a bad experience. So, top of the talk, I said performance is about user experience, so let's talk a little bit about that. Google has done a lot of research, as they do, on browsers and UX. So they have found that you need to respond to your users' actions within 100 milliseconds, or users are going to start to feel it. Respond is the R in Rail model, which is this model that I'm talking about. So this means that you need to make sure to process the actions within 50 milliseconds to give times for other work. So 50 milliseconds is what's called a long task. You also, again, need to produce the animation frame in 16 milliseconds, or you're going to drop frames and you're going to block the loop, and then animation frames are going to start to feel choppy. And this means you have to have all the setup done in 10 milliseconds because the browser needs some time to actually render the frame. So you don't have a lot of time here, there's a lot of stuff you need to do, like say loading a giant application filled with a lot of text and images, maybe with some video conferencing. You're really going to start to feel it. So I also can't help but talk about this. I was reading this book a few years ago called the Every Computer Performance Book, and this guy said that the application is rarely re-engineered unless the inefficiency is egregious and the fix is easy and obvious. But so the alternative presented by this person was to move the code to a faster machine or split the code over several machines. We can't do that, right? So unlike on the back end, we don't have control over the computers that our code is running on. So people can have anything from a souped up M3 Max, is that what we're on now? All the way down to a 2-core machine with who knows what other spyware is on it. But we still have to make it quick. So that's the thrill of front-end performance. So as I said, Slack is a React app in Electron. So you all are probably familiar with React, but it is a popular framework. It's used in a wide variety of applications, from toy apps all the way through enterprise software like Slack. Its popularity means that it's well documented, and there's a lot of solid developer tooling, and there's a lot of libraries. 7 or however many years ago, Slack chose React. I think they were just starting to modernize when I got there. However many years ago, it was like the thing to choose. But yeah, so one of the key things to understand, what I'm going to talk about very soon, is that components get data as props, or they store data in component state. So you can see here, this avatar component, it is getting person and size as props. And then here is a use case of it. See, it is getting passed a size and a person as the props. So this is the data that it's going to use to render itself. And then a change to the props or the component state is going to cause the components to re-render. So React crash course. Redux is a state management library that can be used to supplement component state. So at large scale, component state and just passing pops around isn't going to cut it, especially if you have a lot of shared state. Like say you have a list of channels that a lot of components are going to need information about. So what happens is the data is read from Redux via selectors. So you can still pass props in, like we're still passing in ID and size, but this component is going to use the useSelector hook in this case to grab the person using the ID from Redux, essentially. So this is a connected component, which there's a lot of connected components in Slack because they're all connected to Redux, and that's where the trouble starts. All right, so here is a little diagram. So you have Redux in the middle, and all of these are connected components. Yes, even emoji are connected to Redux. So that's what happens after years and years and years of building things. You need something, like emoji needs to know something about some amount of shared state, so connected. All right, so the way that Redux works is actions get dispatched to Redux, which causes the reducers to run, which updates Redux state. So say the last timestamp of a message in a channel is updated, and we need to like persist that into Redux. So you dispatch an action, and then that happens again. Someone reacted to a message somewhere, and that comes in over the WebSocket, and we update. So that is, again, another action that gets dispatched, and the Redux state gets updated. Then Redux sends out a bat signal. I like to call it a bat signal. It's a subscribe notification. That's actually what it's called, to every connected component. So this is a toy, right? And there's still a lot of connections here. So this subscribe notification goes to every single connected component on the page. And then, hopefully, this is starting to get really good, right? We're starting to get into the meat of this. So everything connected to Redux is going to, check. That's the spoiler. Everything connected to Redux is going to check to see if state has changed. So a lot of components are checking to see if state has changed. And then if state has changed, which it probably has changed because otherwise the subscribe notification didn't get beaconed, it's going to recalculate all of the connected props. So every single connected component needs to run all of its selectors to check, to recalculate, to see if any of its props just happened to change. And then anything that changed, any props that are not reference equal, we'll say, need to re-render. So recap of the loop. Actions cause reducers to run, which updates the store. The store then sends a subscriber notification, that bat signal to every component, which causes maybe a re-render. And then, so this Redux loop is going to happen every single time there's a dispatch. So every single time Redux gets updated, the whole thing happens. Good question, right? How does this go wrong to cause performance issues? Well, told you it would all come together, right? So all of this Redux work ideally should be happening within an animation frame. So we're not causing bad experience, but we're not. Let's pretend this is now. But even like a year ago, we were still in this like place where even P50, so more than 50% of the time, this whole best case animation frame was happening at was at 25 milliseconds. And this is like hands off the keyboard. You're not typing. Shit's just coming in, excuse me. Messages, RTM events are coming in over the WebSocket, and it's just, the app is just updating itself to show you the new information that it just got. So yeah, P90, just to show you out loud, the P95 here was 90 milliseconds, so it's hovering around 100 milliseconds here, which means that 5% of the time people are noticing based on the Rail model. And then P99 was hovering around 200, so 1% of the time the animation frame was taking, like 200-ish milliseconds, so bad. All right, so what does a good performance engineer do? They profile. So we, turned on the the Chrome profiler, and we saw a whole lot of, there's like nothing in particular. So like usually what you do, you profile, you find the thing that's bad, you make it faster, and then you rinse, repeat until your app is faster. But here it's just, it's like a whole lot of paper cuts, right? You could be like, oh, well, what about the gold ones and the purple? The gold are garbage collections, and the purple is a style recalculation, or like we can like make that style recalculation better, but like we got to use memory, and it's got to get collected, the garbage, and then everything else is just like, we have to figure out how, like, what do you optimize? You have to optimize the whole thing. So we had to take some novel approaches to taking the bulk out of this. So pretty much, how can we make less work happen during every loop? We had to take a step back and figure out where performance was breaking down here. So ultimately, it came down to three main categories of things. One, again, surprise, every change to Redux results in the subscribe notification firing. Redux notification means that all selectors for all the connected components are running, which means we're spending way too long running selectors that might not even result in a change, and we're spending way too long re-rendering components. Spoiler alert, often unnecessarily. So The first one is, so because Slack stores all of its data in Redux, there's a lot of updates. So updates, these dispatches are happening on API calls, WebSocket events, user interactions. These all cause a dispatch, which causes a subscriber notification. So every time you switch channels, every time you send a message, every time you receive a message, even if it's not in the channel that you're currently looking at, every time someone reacts on a message in a channel you're in, even if it's not the channel you're looking at, custom status, all of these things dispatch subscriber notification selector. So for large enterprises, this can be happening hundreds of times per second, so we had to do something. I never actually saw the hundreds of dispatches happening per second, because there's some other stuff I'll talk about, but yeah, it can get pretty bad. Then the second phase of this is a lot of selectors. So again, if there's anything to take away from this, in Redux, every connection runs every time Redux notifies. So we added some logging, and practically it was 5,000 to 25,000 connected props being calculated per loop, which again, you have 16 milliseconds. So, but if every check takes 0.01 milliseconds, that's already a long task in this lower bound here. So that's already 50 milliseconds. So we've already way surpassed our budget here. And then thirdly, unnecessary re-renders. So what's happening here is components are receiving or calculating props that fail React's equality checks, which out of the box is just a reference equality, but they're deep equal. So we're just tricking React into thinking that something changed when the data hasn't actually changed. So this happens a lot, or was happening a lot. A lot of times it was where there's a selector that pulls some data out of Redux, like say an array of user IDs that maybe includes the current member's user ID, but we want to filter out the current member's user ID. So that's a new array every single time, even though same data, different array, React freaks out. I got to re-render, even though it's really not receiving different data. Also, this happens much in another popular case, which is returning an empty array or an empty object from the calculation as default. So say you run into some case, you will return early. The type that is being returned from this is array, so I'm going to return an empty array. So you return that, and that's a new array every single time. React, gotta redecorate. Okay. And then passing anonymous functions as callbacks. Again, not reference equal to last time. Anonymous function, passed in as a callback. New prop. You get it. All right, yeah. So how did we start making it better? Doing less work. So that's the end of the talk. But seriously, doing less work. We just had to figure out where were we doing work that we didn't need to be doing. And this came in two sections. So one was targeting problem components. There were some components that were worse offenders than others, and then broad spectrum solutions. We just had to figure out how to do this everywhere. How could we do less work everywhere? But the first one, so Slack, this is Slack. You're probably familiar with it. One of these, we found that one of the components was extra problematic. It's on the page right now. What are your guesses? It was the channel sidebar, the purple strip over there. So, yeah. So we had a hunch. There's a lot going on in here. It looks like a list of channels. You'd think it was this, but we were running some natural experiments. I think when I gave this talk last a year ago. Now since then we the new UI came out, so the channel sidebar isn't on the page all the time. So people who were having trouble with their performance in earlier cases where their performance was still okay on the other pages, they're like, oh, well, my performance got a lot better when my channel sidebar wasn't being rendered. Like, I wonder if the channel sidebar has anything to do with my performance problems. We're like, yeah, we know, but so we were, yeah. So we really honed in on it because of that revelation. I need to check my speaker's notes to see if I missed anything. I did not. Okay. So again, we profiled to see what we could figure out. And so I thought this was going to be the problem because due to reasons, every single time we render the sidebar, we have to recalculate what's being shown in the sidebar. So I thought this was going to take a long time because it's a lot of work. But it of course, it was just connected components, running all of their selectors, doing all of that stuff. And to like really force this to make it extra bad, I put my sidebar into bad mode, which is showing all of the conversations. If you take anything away from this talk, it's that you should have your Slack on unreads only in your sidebar, and your performance will get a lot better. But I mean, hopefully not now. I think it might be okay now. You know, give it a try. But yeah, so clearly the React and Redux was a lot worse than running some generic JavaScript to group channels into channel sections. And why was this? Again, a lot of selectors. So 20,000 selectors dropped to 2,000 when the sidebar was hidden. Great. Now what do we do about that? So we also learned that inefficiencies in lists compound really quickly. So if there's 40 connected prop calculations in the channel sidebar, or in each like channel list item, then times however many channels you have in your sidebar, you can see quickly how unreads only might save you some time. And then like if 2 of those are slow, then you've then compounded your slowness. It turned out that some of them are unnecessary. One of the biggest issues there was repeated work. So a really concrete example was, so like many applications, we had an experiment framework. So it was like A/B testing. We want to like try something on some segment of users to see if it works, if it caused more money to happen, stuff like that. So what would happen is people, like, it would be an experiment that might affect, say, like the display of a channel, of like a channel item in the sidebar, but it had nothing to do with anything to do with the channel itself. So all we needed to know was if the user was in the experiment. We didn't need channel ID at all, but that experiment check was happening in every single, you know, n number of times. So from what I hear, passing props to connected components might be an anti-pattern, but in this case, if it's going to save you a lot of time, you know, pass the thing in. Getting a little bit ahead of myself. But there was also some unnecessary work that was happening. Like our components weren't specialized enough. So like DMs needed data that public and private channels didn't need, and vice versa. Like if you have the pref on to show that someone's typing in a DM in your sidebar, we only show that for DMs. It has nothing to do with public and private channels, but yet we would go and grab that pref even for public and private channels, and we were just going to drop that data on the floor. So little things like that, where you're just like, now we don't have to do that 60 times even. All right, so this is, I got a little bit ahead of myself. So yeah, remove repeated work to the list level and pass it in. And you know, because that's React specializes in passing data to child components, and create more specialized components and delete unused props. You know, really high, sophisticated performance tips here. And just doing that, we were able to reduce the amount of time spent doing React, and like the whole thing, by 30%. That's a good number. I like that number. Still way too slow, still dropping frames, but dropping 30% fewer frames. They were able to see this, see some improvement in overall Redux loop time. So the amount of time it takes to do that whole bat signal thing. Still not totally within the 16 millisecond limit, but we're getting closer. Another thing we did after this was list virtualization. So at some point we had decided we were going to go all in on scroll speed, but there was a trade-off. It was like the more we virtualized, the worse scroll speed was. So we're like, oh well, if we like virtualize less, then people can scroll their sidebars faster. But turned out we probably took the wrong trade-off. Performance is a lot about trade-offs. So list virtualization was a good thing for us. We do it everywhere, but for some reason we thought the sidebar we could like increase the overscan window, which is like the stuff that's not in the viewport that we render. So, you know, you win some, you lose some. You make the right decisions the first time sometimes. All right, so broad spectrum solutions. So improving the performance of just the problem components didn't change the fact that, you know, Redux was killing us, and it was a diffuse problem. So we needed to do some stuff that was going to affect the app at a broader level. So one of the first things we did, this even predated my time at Slack, so I don't even know actually what the performance was like before this, but we batched our React updates. So out of the box, every single time a dispatch happens, the whole subscriber notification happens. But by wrapping this, by only doing one subscriber notification for every single per animation frame, we're able to like make the app usable. Otherwise, it wasn't usable. So it's cool, and we just wrapped everything in this pseudo hidden React DOM API, and easy, I guess, if you consider tinkering with the innards of your framework. Easy. So another thing we did that's a bit more accessible was, I guess, if you like the AST, is code mods. We figured out that we could detect performance problems at the AST level, which is interesting. So we were able to write some code mods that was like, okay, well, like a low-hanging fruit one is like, oh, well, I can see that we're passing literally like an empty object or whatever to a new component. That's going to be a new empty object every single time that component gets rendered. So then its children are going to get the new empty object. So if we could swap it out via code mod with a empty object constant, we could potentially be saving some re-render cycles. So that's an example of one of the things that we did with code mods. We'd also be saying, why are you still using Redux? So we tried to use it less. I think this ended up being a bit of a dead end, but we were tinkering with trying to use IndexedDB or some other form of structured persistence to store evicted items. So less data in Redux means fewer loops, because every single time we like refresh a channel, like not in the browser refresh way, like unstalify a channel, I guess, that it's an update in Redux, which causes the whole loop, even if no data actually changed. So if the data is not in Redux and we still try to update it, then no Redux sleep happens. And you know, cache eviction, it's great, but what if it wasn't in Redux to begin with? What if you're not storing it? A lot of times we ended up storing data that we never ended up using again. So I don't think we actually really looked that far into it. Most of our cache eviction was just based on time. And then finer grained subscription. One of the whole problems with this, right, is that like you update some prop on a channel and it causes the whole app to re-render, right? But like, what if components that only cared about channels only tried to do their selectors when channels was the only thing that changed? Like, that would be cool, but it's just like that's not how Redux works. So it was kind of a bit of a mental shift to start to think about, and it was even harder to try to implement. This was our white whale solution, but it was hard. So we had to do some other stuff to make sure that performance just wasn't getting progressively worse while we chewed on that bit, which I will leave open for now. All right, so if we can't even get finer grained subscription with Redux, why are we still using Redux, right? So this was the question, we started asking it years ago. We tinkered to come up with a solution, but it proved to be challenging to rewrite a whole new state management library while, making feature improvements. Even when there was a performance team, the performance team was 2 people. So we just didn't have the bandwidth to create a new state management library. Also, that's a very different task than performance. And then existing out-of-the-box solutions we just couldn't use. I think it had something to do with the fact that we had actually 2 Redux stores. I don't remember. Please don't ask me in QA why the stand or whatever wasn't useful. And then, funny side note, when I gave this talk last year at QCon, the Redux maintainer team reached out to us to try and figure out what our problems were. And they were like, oh yeah, you scaled this thing way, way more than we could have ever imagined. So that was a bit validating, but also demoralizing. So oh yeah, we don't even know. Yeah, no, finer grained subscription is not what we're selling. Sorry. But they were at least supportive, I guess. So, yeah. But, all right, seriously. So, why are we still using React and Redux? Well, as I said 38 minutes ago, according to my clock, well, I guess you could say that was 8 minutes into the talk. We're using React for a reason, because it is popular, well-maintained, and easy to use, and there's a lot of documentation. It's still, React was allowing us to build Slack with an ever-growing team. We were able to build features with confidence, modularity, velocity, etc. We chose a system that was popular and people-friendly and allowed people to remain agnostic to the way that React and Redux works. Y'all probably know more about how Redux works than a lot of front-end engineers, especially even the front-end engineers before I started this whole performance team. I didn't even know all of the stuff about React and Redux when I was just working on search. This system was starting to break down at scale as we pushed the limits, and these problems were systemic and architectural. So either we had to change the whole architecture, or we had to put in the time to fix it. So yeah, we could put all our efforts into choosing or writing another framework, or we could, write our own thing, that solves the problems that we have. But this would be a multi-year project to come up with a really robust, or we thought it would be a multi-year project to come up with a robust new drop-in thing, or make it as drop-in as possible, right? And there's no silver bullet out there for us. Slack had over 200 front ends, so changing everything would be a huge lift. We'd have to change the whole state management system, right? There were reasons why we'd chosen Redux. There's consistency, there's approachability, and its trade-offs were those over performance to some extent. But every other architecture is going to have a different trade-off, and we just didn't know that yet because we hadn't scaled those. So it's kind of like the devil that we knew. So we decided to push forward with mitigating the paper cuts that were happening because of Redux. And yeah, I thought this was a viable path. This was something that I pushed for a lot. So I decided to lean hard into creating performance culture and teaching everyone, how the system works, because I think understanding how the system works, all of that background that I gave you that kind of felt like it was going a little slow, right? Now, having all of that context really helps you understand exactly how the system was breaking down. And when you have that understanding of how the system was breaking down, then you're more equipped to write better code and to fix the problems that arise from that system breaking down at the edges. So I believe that engineers, like you all, fundamentally want to create performance software. So I was really pushing, and I pushed to give them the tools to set them up for success. So I've wrote a lot. All that stuff that I talked about in slide form, there was a Slack post. So yeah, again, understanding the system contextualizes and motivates performance work. So a lot of English was written. That's staff engineer for you. A lot of English was written. But there was other tooling that I wrote. So another key part of this was making people aware of the issues that were happening. People were writing code, they didn't realize that they were creating a paper cut. So lint rules are a great way of surfacing with no intervention when something has gone wrong in code that can be detected via AST or whatever. So there were some lint rules that we could just drop in via a library. The React perf ESLint library is one of those things. And we also wrote our own lint rules. Like, we were able to detect when there was going to be an unstable prop that was computed for a connected component, or a function or value that's going to break memoization, but it didn't have to. So I have it on good authority that helped people write more performant code. We're also, when that didn't work, console warning. Sometimes you can't tell if the code is going to create an unstable value. So we are able to say, okay, well, I'm going to remember what was the last value? What was the value we just got from the selector? Are they deep equal, but not the equality that the component was expecting? So not reference equal or whatever. Then also finished experiments, whatever. But yeah, the big one was unstable connected prop calculations. We could, in the console, give people a warning like, hey, your component's re-rendering when it doesn't have to. You might want to look into it. And then we finally got regression testing, but not in exactly the way that performance regression testing canonically happens. So we were able to take the module that backed the runtime warnings and say, hey, in test, we noticed that we had detected an unstable selector. You might want to fix that so that you can merge your code. So a little bit of a detour. In like canonical performance regression testing, right? You like run a thing, you see how many milliseconds it takes, you compared it to when the new code wasn't there, and if it's more time by a certain amount, then you fail the test. But those are unstable. There's a lot of setup. There's a lot of unknowns that can happen in a headless browser or whatever. So getting a system that was and what's the word I'm looking for? Like reliable. It's like there should be 0 and now there's 1. So fail, not this took 300 milliseconds and now it takes 305 milliseconds. Maybe that's a fail, or is that just normal variation? I don't know. And especially because we knew that our problems were paper cuts and not catastrophes, this type of testing, the canonical performance regression testing, just wasn't going to help us stop the types of performance problems that we were seeing compounding. And I kind of touched on this a little bit, but education equals empowerment. So a lot of just posts about, hey, so you're seeing this lint rule pop off, or you said this component console warning, like this is how you fix it. And building little things like use shallow equal selector, we had to like build our own. So instead of the usual reference equality in this hook, it's shallow equal. You could get a little bit more room. You wanna use that map, you wanna do that filter, like fine. Just like use this hook instead of the one that came with the library. Then, now the component is stable. And probably the trade-off of doing that shallow equal check is gonna be better than the trade-off of re-rendering the component. But like, maybe not, but we're just gonna, rely on that. And then use memo and use callback are good ways of stabilizing props and just like teaching people about the tools at their disposal. I think use callback and use memo, they're going to happen by default in React 18. Don't take my word for it. We were still on React not 18. And I think it was just starting to come out the last time I checked. But I think some of this stuff, like the React team's like, oh yeah, we made some performance foot guns and we're just going to smooth those over for you so you don't have to do all of this. But we didn't get to, reap the benefits there. At least there's probably still not on React 18 yet. And then, because everyone loves a graph, everyone loves a program, everyone loves being called out that the component that they just built is the one that has the highest number of runtime warnings. So I created a burn down program. Making people aware that aware of the issues happening is the first step in getting the issues fixed. But, sometimes you need a good chart to motivate people. And for the most part, it worked. So like to joke that performance work is like fighting entropy. And we successfully figured out how to fight entropy there. It's like, for physicists, that's the entropy going down. All right. So in conclusion-ish, so performance has been built up as a problem for experts. This is what I've found. I am, I guess, one of those experts. But we're doing ourselves a disservice if we keep this as an inaccessible discipline. So I think what we should do is we should get as many people to fix as many problems as possible, which is, worked for us. I don't know if it would work for every single application, but based on the nature of our problem, where there was this paper cut thing, where fixing every single paper cut was just like one little extra thing that people had to do. If they understood how they were offending the system, then they might know, oh, okay, well, I need to add this use memo. I might need to add this use callback. Oh, well, I needed to put a filter in this thing, so I'm going to use this special hook or this special create selector to kind of smooth over the instability that I just added. And I think we can start to chip away at our performance problems. Or you could just figure out how to fix the whole thing. So the whole thing about, finer grained subscription was really hard. We got our best JavaScript engineers to use weak map or something. And we figured out how to bolt finer grained subscription into Redux. And we got the green gains. So this was a bit, like ship of Theseus, where if you change all of the components in something, is it still the same thing? We had written our own version of connect and use selector, which are the ways that each type of component connects to Redux. So we were able, well, if we rewrote that, well, why don't we just add this filter thing in? So pretty much we made it so that when a selector would run, it would be like, okay, well, I only touched the channels store and the member store. So now I know that those are the only slices of state that I cared about. So the next time the component ran and tried to run the selector, it would check to see if those slices of state had run via some registration with, I don't know, these people are really, really good at JavaScript. They work on Electron. Yes, we were able to pretty much short circuit running the meat of each selector if the data that it didn't care about, or if the data, able to short circuit running the meat of the selector if data that it didn't care about was the only data that changed. So performance got better. And that was about when I left Slack. That was, this screenshot was exfiltrated to me. Yeah, it's kind of I gave this whole talk about, trust your people to solve the problems, and then we just ended up going and just getting rid of the whole, root cause. But I think both approaches have merit, and we were able to buy a lot of time to finally be able to come up with a solution that kind of wiped away a lot of the issues. It also has trade-offs, right? Like, we need to check to see there's a check at the beginning now of every selector that checks to see, okay, what data does this selector care about? And that could be more expensive than just pulling the data out of Redux. So again, there's trade-offs, but if a lot of these selectors are doing that map filter or whatever, and they are more than just indexing into the Redux object, then we do end up saving a lot of time, as seen here. All right, so the end. It takes a lot of work to do less work. That's just a mantra that's been rattling around in my head, and I'm gonna drink some water now. Thank you for listening.
So you mentioned that the Redux team actually collaborated with you to try to troubleshoot the problem. So it sounds like Slack was kind of on the forefront of this sort of problem. Do you know if there's other companies that had similar problems, and if not, do you know why?
I don't, the Redux team said that we were by far the biggest implementation of Redux that they'd ever seen. And they were like, we're sorry, we built this thing. We don't really know how to fix it. So I don't know, big apps decided not to use Redux, or they decided to switch away from Redux to an alternative. They had this system and architecture that was capable of making that cut. They made a better decision earlier in the game than we did, I'm gonna guess, or I just haven't heard about it. No one's reached out and been like, we have this problem too, thank you. Probably because most companies aren't really forthcoming with their issues.
Yeah, it's hard to do that at large scale sometimes.
Yeah.
You don't have that.
What did you find were the best resources when you were sort of diving into the internals of React and Redux? Was it just close reading the documentation, or were there better places to look?
Yeah, a lot of it was reading the documentation. This was some amount of years ago. At this point, I feel like I have the mental model built. But specifically about React and Redux and learning about that, or performance more broadly?
I was thinking of those two.
Yeah. A lot of it was, just reading the docs, reading the code even a little bit. At the point where useSelector and Connect, which are the two places where I'm really caring about, because those were the way that the components connected to Redux. Having those homegrown, we had rewritten our own, so there was I spent a lot of time in those files, so I really got to know them. So there were some intricacies there, especially I had to rewrite Connect to use useSelector so that we could add the finer grained subscription in there, so then I really understood how Connect worked. Reading documentation, also talking to coworkers who seemed to understand it more than me also helped. This might be one of the best resources now for how React, the most accessible, because everything else wasn't super clear,
Question for you, probably a managery question here, but you mentioned as you were debugging it yourself, you open up your Chrome, your dev tools, and kind of looked at the burn down charts and all of that. How, kind of taking that a step further, how were you able to, in the absence of the regression test charts and everything, the regression testing, how were you able to confidently demonstrate that the work you were all doing was having an impact, a meaningful impact, other than look, it's faster on my machine?
So we had metrics. So that's this guy. I'm not sharing anymore. There we go. So we had a lot of graphs like this.
Is that Datadog?
This is homegrown something or other. So a lot of tracing was occurring. So we would like beacon every however many. And then, yeah, this is just like I pulled it out of our data warehouse and made a graph. We also had 3 other metrics, but we really didn't need to like prove it to anyone. Mostly, I feel like it was not like a wasn't like a hostile situation. Everyone was just like, yeah, we know performance is important, and we want to make it better. And like, as long as the graphs were going, even if the graphs were going in the wrong direction, it was always just like, why did this get worse? And that was the hard question. The why did it get worse was the hard question. But does that feel free to ask a follow-up.
I have follow-up for
Yeah.
it actually. Like, so you did you have to build this graphing on your team, or like was there graphing before that? How much effort did you put into real user measurement on your team, on performance team?
The graphing itself was not us. This was like any data that you pulled out of our data warehouse. So we kind of even like co-opted it for performance. We also had Honeycomb, but this was a bit easier to use because, I don't know, Honeycomb, you can't do that much operations on stuff. I love it as like a baseline. You need to see what the tracing is doing. But when it comes to graphing things on top of each other, especially for months and months and months, I don't even know what library they were using to build this. But yeah, it was like you'd write some SQL and then this would pop out the other end. Great.
Kind of follow up that. So it sounds like you, before this team even was created, you had like kind of the foundations were there
Yeah.
to say, hey, like we recognize this as an issue, and you didn't have to like start the collection from zero.
A lot of the collection was started from
Okay.
zero. Like how long is Redux taking? What's our input delay? How many long tasks are we doing? How long is the channel? The channel switch was already there. But yeah, we had to, the mechanisms to collect the data, we did not have to build from scratch. Like even like how do we do a trace on the front end was already built. But we had to add using that existing library that someone else had already built on the front end infrastructure team. We had to then use it,
Okay.
which
got it.
puts us in a much better position than a lot of but you know.
Yeah, not everybody is lucky. Yeah.
And I'm wondering as I start a new job what that's going to look like. So I might show up next week looking a lot more hassled.
Were there any performance issues that you found kind of just by virtue of running in Chromium that wouldn't have been an issue if you were just like running it as a web app in Safari, and maybe you have like different, like Safari is faster at certain things?
We really only paid attention to Chromium. Like, we have the data, we know when someone's user agent is whatever, that's not Chromium, but just because most people are using the desktop app, and that's where most of our experts were experts in. I'm trying to think if there were cases where we would, kind of the flip side, we would run into performance issues because of something that had happened in Chromium. We were able to pinpoint it because the version of Slack would bump, and then the graphs would diverge. So that was interesting to see. And then I guess we were kind of lucky because the folks who work on Electron are really tied into the Chromium community. So we were able to closely follow and influence and learn about those types of bugs. I can't think of anything, I can't remember specifics, but there were definitely times where we were like, oh, well, this Electron version corresponds with this spike, and then level off. Yeah, does that answer your question? Yeah.
I actually have a philosophical question. You mentioned culture of performance, that it's
Yeah.
important, and turns out you could do hard coding in the guts, but culture is still important, right? Like as you said.
Yeah.
do you have any advice on how to make performance is as clear topic as tabs and spaces, or dark mode for developers, or code formatting, or whatever else is today is considered normal, or tests? Do you have any recommendation of how to do that for performance aspect of it?
Well, tabs versus spaces still has contention, right?
But everyone cares.
Do they?
I mean, there is contention.
I'm
They
buying
must
time.
care, right? I'm making a joke a little.
Me too. I think part of it is tabs versus spaces, or like what editor you're going to use that feels accessible and like something that everyone, it's like an entry level type of, everyone needs to figure out what their preferences are. And I think, yeah, just like breaking down performance in a way so that people can understand it, and it's not this like, oh, I have to be a staff engineer to really think about performance. Like teaching people, I mean, I think kind of like what I did, how to be an agent of performance just with little tweaks versus really large scale investigations. And I did actually find that the more that we got people to wrap their head around performance, there were a lot of people who are like, why are we doing memoization? Like, what about all the memory that we're using for memo? And like why, we have a memory problem, right? And like, it did kind of feel like a tabs versus spaces type of thing. The people felt empowered to like bring up those questions in a way like they wouldn't have been thinking about it before. So I don't know if that's kind of a weird answer, because it's a hard question.
Yeah, I mean, you actually had it in the presentation. You wrote English, like that was like very important. I feel like it's not only about tech, right? It's not only about writing JavaScript, but writing English as well.
So that was meant to be a softball question that I missed.
No, not a softball for sure. Anybody else? Any more questions, folks? I mean, we will have some networking afterwards, so you can just ask your own question as well. So, okay, thank you very much. Thank you, Jenna.